Hey everybody, welcome back to my electronics workshop. So I'm finally going to get to the recap kit for this EICO Model 324. It's a signal generator. This one's kind of got some sentimental value, which is why I'm really putting the time into it. Not that I really need it, but it's kind of a handy piece of equipment to have around, especially when you're working on old radios and things like that. So I have kind of gone through and cleaned this up, just gave it a general scrub down. Did have to replace a few knobs on it because they were missing, but I just dug through my parts bin and found something that would work well enough for my purpose. So they're not, it's not a parts matching, serial number matching type of thing. It's just more of a fun piece of equipment that I want to get back together. So anyway, let's open this thing up and see what we have to do to install this kit. And I believe I got this kit from the same seller that I got a few of my other kits from, which was, I believe it was Infinity for something. Let me just quickly navigate to my eBay listings and tell you eBay. I know, I'm just basically waffling right now, but let's go purchase history. I did get that last kit from, let's see, where is it? EICO. Here it is. Peace and Love Music, which I think that's the seller, what they go by. Infinity for Artifacts. They're located in Milwaukee, Wisconsin, so they're just south of me. So, but yeah, they seem to do a pretty good job with their kits. I'm fairly impressed with the complement of parts. I can't really say anything bad about it, so everything that comes in the kits are pretty well, pretty much what you need to do the job and get it done. So, on the Heath kit, the IP32, I just noted, and it's obviously, it's not even that big of a deal, but I noted that I did put an upgraded voltage value in the main output capacitor side of that, because I was if the regulator tube ended up failing, or if you pulled that out of circuit, it would actually exceed the 450 volt capacitor that was in there. So the rest of the capacitors would have been fine, perfectly fine with the voltage, just that one capacitor. So I went for putting a 650 at, well, I actually had to put a pair of them in there to come up with that value with what I had in my parts bins. But I would do a 650 at 40 microfarad, 42, somewhere in that range would be fine. So, okay, let's crack open this EICO and start working through it. I did do a little bit of cleaning and polishing up on the face, washed the housing. It has a little bit of rust pitting from all the years of use. So I'm not going super far on this one to really make it perfect, but I could have stripped the housing, and I could have gotten some wrinkle coat paint and resprayed it. But this particular piece of equipment is going to be a workhorse, and when I get to the point of really wanting to restore it, the face isn't in perfect shape. It's in good shape, but it's not in perfect shape, so it's not a restoration quality piece of equipment. But trust me, I do love this old test equipment, and it all deserves to be repaired and made functional. But sometimes the purpose is to just get the thing working so that you can use it and clean up and do what you can with what you've got. So, okay, as you can see, I've already replaced the line cord. Went through this process already, kind of in preparation for the cap kit, because, like I said, sentimental. This was given to me by a near and dear friend whom has now since passed on, but the pieces of equipment that he has given me have never left my my hands. So someday I may hand this down, but I think it needs to just be used. So we still have the old paper and foil type capacitors. The old electrolytic is still in there. So that's that, and that's going to be these two capacitors here. Those are going to replace the single paper can type, and then we have a bunch of foil type capacitors here, which we'll have to go through. And then I'll have to hook up my oscilloscope, which I'm going to go ahead and turn that on now, because we're going to mark the foil side on those. It's just a good practice, especially when you're dealing with anything that is RF based. You want to put the foil side as close to ground as you can to eliminate or limit noise introduction. So, great. All right, let's get to it. This is going to be a bit of a process because we got a fair bit of stuff to replace, but it's a pretty simple piece of equipment, so this shouldn't take too terribly long. We do have one diode to replace, and it appears that that is the diode right down in there. It looks like it's a germanium type, or maybe even a selenium glass type. I think it's a selenium glass type, at least the way that I'm looking at it. And we've got a capacitor across the line cord, which is likely a safety type capacitor, and that needs to be replaced. In fact, that should be replaced with a very specific type of capacitor. That should be an X-rated, I think an X-rated. The way that those fail, that's the whole point, is when that type of capacitor fails, it, instead of failing shorted and sending the voltage directly to the housing, because these don't have polarized line cords by the factory, so you have a 50-50 chance of getting it right or wrong. If it failed in a certain way, it could send your line voltage directly to the housing, and if you grab a hold of the housing, you could get a little shock off of that. And again, depending on where you live, it's 110, 120 volts. It's probably enough to let you know don't do it again. Doesn't feel great, but it's usually not deadly. But there are niche cases where it can be, especially if you have health issues. So that's going to lead me into the next part and the safety briefing of what I'm doing today. We are dealing with elevated voltage in the vacuum tube circuits. So if you are doing any of this on your own, you're doing so at your own risk. I accept no responsibility for you electrocuting yourself, killing yourself, or all of that put together. So don't come chasing after me if you done stick something in there you shouldn't and end up having big problems either with death or property damage. So there you go. Okay, so let's take a look and see what we got going on here. We got a bunch of paper capacitors, paper foil, waxy jobs. They all need to go. They all need to go to make this thing work correctly. We may end up looking at the resistors just to make sure that they're in a decent shape to be used. This may be a multi-part video just as a heads up, but let's go ahead and get started. first things first, I want to start with the one thing that ends up basically holding up the show usually. So we're gonna get that waxy double capacitor out. I do need a way of setting this up where it's more convenient to work on. I should have an over top camera, an overhead camera, but I do not. So this is some interesting assembly going on. Things are kind of just stuck down, but not actually properly installed. So it's good we're in here. This was likely a kit build, I would assume. So it's not uncommon to see some kind of questionable assembly in the I build it kit type of stuff. But since we're in here, we'll go ahead and make some corrections to help things work just a little bit better. Yeah. And that came right off. So we gotta remember where that goes. And we'll put a little loopski-doopski in here. And we will hook that in. Again, we'll have to test this out to see what that capacitor looks like. That was hot. Alright, let's nip that garbage out of the way. Okay. There was a little bit of damage in here from some reworking, but we can deal with that. That's fine. Let's go ahead and get this in a good position. Okay. Cords are always tangled up. Why is that? That is electrically acceptable. Is it perfect? Perfectly usable. Does that count? Okay. Yeah, there's definitely been some interesting reworking at some point that's been done. I don't know. It looks to be pretty much untouched, but there's a few things that kind of say otherwise. That's okay. We can get this right. So that's gonna go there. I like to mark my stuff. So positive. And then we're also dealing with a positive there. And then negative is in a very interesting spot. I think we're gonna have to do something about that. I'm not a huge fan of that location, but we'll see. Well, might as well. There we go. That wasn't even stuck in there really at all. Okay, we've got to loosen up a nut on the transformer to get this capacitor out of here. And since I'm always deeply curious of the capacitors that come out of these, on how bad are they, we will hang on to it because I like to go through and just say, hey, what are the odds? I could turn it into a gambling situation. Not gambling as in leaving it in circuit, but, you know, is it still good? Okay, so now we are at that point where we need to make some decisions on how do we want to assemble this. I'm not a super duper big fan of how they have these laid out, but I'm thinking about, yeah, I'm gonna put a standoff in there to give my ground point, because there really isn't a great spot to put those capacitors the way that they had them mounted. Do I have just a single grounded standoff? That might be a usable candidate right there. I do not throw away any of those, because I am a hoarder. And I just dropped it. Okay. Well, let's clear out some of the crud on this one. Oh, poop. Oh, I gotta fix that. It's not the easiest housing to work with. we're going to have to do an alignment procedure on this anyway, after all this is said and done. Okay, we're back. Okay, now, how can I do this? If I put it right there, I should be able to use that as a connection point. So I think that's what I'll do. Take the screw right, or take the thing right back out from the original mounting point. Generally, you want your grounds to all come to the same point on RF related circuits because it helps with noise isolation, which kind of just keeps things happier. I think we'll be able to get away with it though. Okay. And we'll put the screw back in. I'm gonna clip, where did I put it? I am going to clip off the other side, although I will probably regret doing it as soon as I do. But we'll cross that bridge when we regret that choice. Yeah, it'll be fine. Cool. Okay, next. Let's put that right there. And the washer. And the nut and the washer that I just dropped right back down there. Sure have that lead in just that really awkward spot. Got it. Now, let's do this. I want to make sure that that's really tight because I do want that to bite in and have a good ground. And I'm pretty flippin' happy with how that looks after I give it a little straightening. Good deal. All right, we're on. We're back on. So those are the components we need. Oh my goodness, there's some really sketchoid, sketchy work done here. That diode was barely installed. That's out. Don't want to throw it away because it is still good, I know that. But let's see, which way were you installed? you're going to be installed that way. Because if we install it the wrong way, it won't provide positive voltage, it'll provide negative voltage. And negative no so good. Okay. I like that. Just like that. Put that lead. Put that lead. I think that'll work. Okay. Now, let's get a capacitor lined up on here. Might actually move that to a slightly different position. Mostly just to give myself a little more room. Yeah, okay. And then do a little something like that. That. Sure. I think that is going to be about right. Okay. And in you go. And Bob's your uncle. That's one. Okay. That seems to be in a position that I'm happy with. And all should be good. Now, we need to install another one. Again, like that, something kind of like that. I think we're gonna jog this one a little bit. Maybe over that way. Maybe right there. And that's going to go over. And right about there. unbuttoned that. Cut off the excess. Don't think Carlson would approve, but that's okay. Alright, let's knot some solder on that stuff. Since we're pretty much done with that side of the circuit. Okay. Oh no. Oh, I'm gonna have to buy another roll of solder here soon. That stuff's not getting any cheaper. Okay, so the excuse me, the electrolytics are installed, and I'm pretty happy with that. Polarity's correct. New diodes in. Now let's take a look at this. This paper and foil one is a 0.01 microfarad, and that is one that I need to make sure is in here. .03, 0.0 or 0.1, 0.1, 503, 103. Oh, sinuses are terrible. All right, we have 3 of those, 2 of those. Excuse me. Okay, I think I'm back. Maybe. All right. 0.01, 0.01. So we do have 3 of those. So we'll start by getting this one out of the way. we're jammed. Of course we are. Okay, we're going to try to clean up a little bit of that wiring too. There's another thing, there is no fuse on this this unit whatsoever, which is kind of a bad design. So it may be beneficial to add one. Ah, old solder, man. So I did note that they had the foil side not towards ground, which again, I mean, it isn't a necessary thing to do in this case, most likely, but it's good practice. It's just good practice. Okay. And I think I'm gonna see if I have a one that I can mount in here. Do I have a little fuse holder available? Doop-a-doo. I do, but is there a good spot to mount it? That's the next one. Can I? Yes, I think that might just work. And if I do this right, I might be able to have the housing still fit okay. I do not want to drill a hole. Oh, I need a self-tapper to do that, really. Let's use one of the original covers. I know you guys are screaming at me, just drill a hole, dude. Yeah, you're right. But I think that'll work. Can I... This is where a stubby flathead would be very handy. Oh god, I just better drill this. Yeah, we're just gonna drill it. I don't want to fight that. Actually, no. I got better screws for that. And it doesn't fit. I'll cut this off with my little rotary tool, I think, but that will fit the need. There we go. Is rather curious on why they did not put a fuse on this. Okay. And I think we'll spec a pretty low current fuse. This is a 2 amp. That should be just fine. It's mostly if something goes short, we don't want to really burn up the we don't want to burn up the transformer. At least I'd prefer not to. Okay. And we'll just get this in place right away. Yep. Oh, what do I have? I gotta have some line cord wire lying around here somewhere. Here's some old stiff stuff. That'll be just perfect. Okay. Okay. Some of you were asking, well, how come you don't just put a grounded plug on this? I don't find the need. Sometimes it's actually beneficial to not have a grounded line cord for the things you're doing. So that's added. And we'll do something kind of like that. Take off a little here. That whole Bob's your uncle thing again. Maybe we'll go under. And if the transformer lead was just a little longer, I would have ran it right to the fuse. That's okay. Trust in the process. Alright, oscilloscope. I'll do a video on this at some point, specifically just pertaining to how to check these. Of course, Mr. Carlson has a little tester that works well with this. That's a build it type of project. I may actually want to build that at some point. So, Black Magic Marker. A Black Magic Marker, where are you? Where are you? Red. Where the black? Where's my black? There it is. And a dot. And I'm going to put the foil side of this capacitor as close to the ground as I can. And in this particular case, it is ground, because Well, it just is. It's the chassis ground. Okay. Again, an X1 rated capacitor would probably be the best to go in this part of the circuit. But we'll work with what we've got. Okay. And that part's done. Now, let's start staring at some more of this stuff and see what else we can do. Well, we know we have two more that are right here. So let's work on those. And I got the foil side going the wrong direction on this one too. That is odd. Flood some fresh on this one. It's not removing easily. Okay. All right. Next one's going to be the same deal, but we're going to save the insulators because why not? They're there. We got to figure out the foil side real quick. Let's just check that out. Oh yeah. If I flip that around, much better. Okay. Makes a difference in the long run. Oh, so let's go Like that. And do some manipulating here because I am not a fan of how this was configured. Might be able to work with that. Yeah. Oh yeah. Looking good. Very strange assembly. We're just gonna cut that and then deal with the bits after, because there was some there must have been some repair jobs or something done with this at some point, because I should really probably look at the schematic and see what the deuce. Okay. I see what's going on. The socket had some damage at some point. That's the other derp burp. Where are you? Right here. And we'll quickly check this. Oh, way out of the craziness, right? Oh yeah. Okay. Okay. I think I'm gonna do something a little different on this time around, because with that socket having some strangeness about it, and I'm just gonna have to kind of do some things. Let's do that. And let's just tin this real quick. And should have a little thing over here now to get that resistor back in. Okay. Yep, that'll work. Scooby-Doo. toss a hook in here. Snot some slobber on there. And I gotta pull some more out. That and that. Just got a couple more to do. Let's do this. That's a bypass cap, and we got another cap of the same. We'll do these two. Okay. And all right, so they got this. They got that in a ring terminal. So why don't we go ahead and do the same, but put a new ring terminal on it? Okay. Yeah. Okay. I am confident enough to say it's that way. Can we just reuse with some gentle persuasion? What do we got? Okay. think we can do the things with that. Okay. And now we just gotta attach this. To that. Oops, come back here. Cool. That's done. Now, what's next? Got another cap here. Okay. Yeah, looks about right. No, yeah, that's all cleared up. Good. Okay. Now we gotta figure out this. this is just one of these layouts where I'd almost think I wouldn't fault anybody for just J-hooking. Okay. Yikes. Okay. Alright, what do we got left? We've got a 0.05 microfarad there. Okay. That's getting jammed up. So that's this one here. Let's check for foil side. Okay. More noise on that side. Okay. So that would mean it's that way. And you're going to go there to there. This one's probably not bad, but let's try. We'll get the replacement in there, and we'll test these anyway too, just to see which ones were good and which ones weren't. And that was a 0.02, and that's the last one we've got. Let's grab the foil side on this one, see what we got. Oh, that's lousy with noise. Let's try this side. Okay, oh. I wonder if it's because I'm hanging on to this. Yeah, of course it is. 219. Well, that's way higher. Yeah, okay. Foil side's going that way. Okay. And that just needs to be blobbed in real good. Okay. That and that, and that makes it. And that's that. Cool. Let's shake out all the trimmings and see if that made a difference. I'm sure it did. But there we go. Let's see. I'm going to set down to bottom, powers off. Good. Okay. And we're powered on. Lights are lighting up. So that's external modulation. We'll do internal modulation, and let's hook it up to the oscilloscope and see how it looks. And once I do that, I'll flip the camera around so you guys can all get your eyeballs on it too. grab higher voltages here. Let's go to 5 volts per division. RF out. And good. So we're on band A. Let's go to, that's 400 to 150 kilohertz. Let's just aim it for there. Do we have output? My 12AU7 is not lit up. Why would that be? Let's have a look at it. Something's not right. Okay. Let's see here. That. So those are the filaments. Maybe that tube is no bueno. 12AU7. Let's grab one. I think I've got one handy. Y7, we're not going to use those. 6BH, H. That's a vibrator. 12AT7, we could use that. So that was a 12. let's just use this 12AT. It'll give us the idea if it's right or not. Power on. No, that tube is not lighting up. Alright, well, let's stare at this for a second, because we should have everything, but we don't. There. Okay. Multimeter. Let's see what we got going on here. That's likely going to be AC, and it should be there to there. We have 6.5. All right. That runs to there. Ah. I think I see what was going on. Let's see if that made a difference. All right, these are 12. What do we got? What's that tube? You're at 12AV7. AV. So there's a 12 AV. And then another 12 AV. What does that mean? What do we got going on here? Meter is on. So I go to ground to here. We have 6.75. We have filament there, but we don't have filament there. We have red gets red. Orange. Okay, maybe I got that diode in backward. Where am I? I gotta go here. Okay. Well, 190, 186. No, diode's fine. $176. So that would be off. It would be on. That's internal modulation here, right? External RF modulation, internal AF. Curious design. Let's look at the schematical. So 4 and 5, 4 and 5. Okay. One, two, three, 4, 5. We gotta run a jumper. I done diddled it wrong. Okay. 4 and 5, 4 and 5. Should have filament. But we do not. Hmm. Nine. One, two, three, 4, 5, 6, 7, 8, 9. Ah. Found it. It was that ground point that I was saying, hey, I should probably redo that. Yeah, I gotta redo it. Live cap. Okay, we got it now. Yikes. Can't believe how they built these. It's a real simple device, but that was a very odd layout. And we should be back. In dysfunction, and we are. Okay. Now, let's hook it up to the oscilloscopes and see what we got. Let's set that to high. We have modulation. Beauteous. Okay. It's not the prettiest. It's going to need an alignment, but it does work. Let's deoxit the contacts here because they are not acting right. Ah, I see my problem. Okay, and we'll fix that. Okay, now we're back in business. Oh yeah. And we got all of our stops in the woo-woo train here. Let's go ahead and flip the camera around. Okay, so we're looking at the oscilloscope here. We're gonna set it to 200 millivolts per division, and let's just set our 0 point. You can see the wave is a little goofy, but let's go ahead and set peak voltage, and let's set RMS, and let's set frequency. So this should be, let's see, 400 should be right there. And we're a little off. So we definitely need to align this. And I believe we should be able to just do that. Right here. That's pretty darn close to 400. Let's make sure we tracked correctly. That should be 350. That's pretty darn close. So that's 350. What's the center of the scale here? So lowest is going to be 150. Let's go ahead and fix our timing here. You know, that's so darn close, I'm almost not worried about it. But I'll take this. That's 150. Let's give it some more amplitude. Yeah, okay. And let's go to 200. Okay. Yeah, okay. Well, I'm okay with that scale. That's fine. Let's go ahead and adjust that. And that's going to be B. Let's set this to 600. And we're a little off, so let's go ahead and adjust that. Oh, damn. Perfect. It's 500. Yeah, pretty darn close, I think. Splitting hairs if we get too crazy with this. It should be about 400. Yeah. Okay, let's go to C. So C scale, let's see, this will be 3.5. Okay, let's change the timing again. And we're off, so let's go ahead and adjust that. We're getting bigger. Topped out, it's 4.2. That should be 3. Okay, well, let's check 1.2. Fix our timing. A. Let's just set this to center scale, so 0 to 100. We'll set it to right about there. So it's 250. I'm gonna go ahead and connect this up to the Agilent. 5 volts RMS. We're not anywhere close to that, so we'll be okay. There we go. 250 point something odd craziness. Okay, that's pretty darn close. I mean, a sneeze on the knob would knock that off. Let's do 700 is right there. That's pretty darn close too. Let's go to C. C, let's go to 2. It should be right there. That's not right. ISC scale should be 1.2 to 3.5. And we're higher than that. Is that a harmonic? Can't be. C. C. I think there might be a resistor or something that's out of whack on that. Because, oh, we have a broken wire. Alright, shutting it down. Is that a broken wire? Yes. Yes, that is. Where do you go? Okay. I think I see where it's supposed to be. Let's see if we can fix that. I'll flip the camera around and then kind of explain what's going on here. So on one of the band coils, I noticed there's a little whisker of one of the coils that is kind of just sitting out in the middle of nowhere. So I'm gonna have to carefully, yeah, that's where that was supposed to attach. I'm gonna have to carefully reattach that somehow. Anyway, I'm just carefully trying to strip some of the enamel off of that little wire. It's going to be delicate. Sometimes you can just flame the enamel off if you're real careful. That seemed to work. Now, we have to reattach that. And I think I might have a plan. Let's just hope it works. I think I got it. Okay, let's see if I did actually get it. And I'm just gonna put the original EICO tube back in there since the tube was fine. Alright, powering back on. And we'll flip the camera around. Let's head back to band A. And stick it at 250, and we're still there. Band B, it's about 700. Yep. Band C. Now, let's just stick that on about 2. And then we'll adjust the coil. Oh yeah, we're in better shape now. Things are looking a lot nicer. And 2. Good deal. All right, band D. Now we're getting down into the nutty grundies. So 3.5 to 11 megahertz. So let's see here. Let's go and adjust that. That is on 6. So we're going to go ahead and adjust this to say 6. There we go. That's pretty darn close. We're going to just get this in the ballpark for right now. Band E is 11 megahertz to 37, and where are we on that one? Let's aim for 20 maybe. That should be pretty close to 20 megahertz on the dial, and then we'll adjust this in to say 20. And 20. There we go. Now band F is a harmonic band, so we'll probably not see anything unless we get into the oscilloscope. And speaking of, let's go ahead and tap in. All right, we'll bring up the amplitude to about 50%. Right about there. Set our timing. We'll zoom in. That should be achievable, right? maybe. Okay. Oh yeah, there we go. It says we're on a harmonic, aren't we? Yeah, we are. Okay. Let's back down the gain. And get the level. Sure. That's 130 megahertz. And topped out, we're at 142. Yeah, it should be 145. And then we should be about 34 is there, 37, yeah. So it's actually looking like it's working pretty darn good. Let's go ahead and back that all down. And fix our timing. Well, now, out of curiosity, what does it look like on the spectrum analyzer? Go ahead and make some slight adjustments here. So let's, what is this? Let's go to, I don't remember how low this can go. Let's go to RF. Let's do 10 megahertz. Okay. Set the gain all the way down, set it to low. I really don't want to damage this, so we're going to be careful. And then we're going to go to the band that's going to give us 10 megahertz. So I would say we can get to 10 on band D. So A, B, C, D. And oh, there it is. Look at that. There's 10. And what does it say on the screen? Da, 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 da. That might be a harmonic. 8, 9. Okay, there's 10. We had a harmonic. So that's 10, and it says 10, and we know that's good. Let's bring in some amplitude. Wow, that's actually pretty good. I am impressed. I am very impressed. Okay, oh, just powered it off. We'll power it back on. So that is external RF modulation. This is internal audio frequency out. So if I was to, let's just say, connect something that produces audio, I could actually modulate that and see what it looks like. So, very cool. Well, the EICO is working beautifully. I'll flip the camera around. Yeah, the old signal generator is working fantastic. We're in good shape. I'm happy with it. I'm going to continue playing around with it, but I got a good preliminary alignment on it so that it's a usable piece of equipment. So anyway, thank you so much for watching my nerdy moments, and we'll catch you in the next one.